Okay, so the fifth session of construction documents, part 2. Fifth session overall. It is 9% of the exam. If you're taking the exam, this is the AIA approved CEU HSU class. The learning objectives were the same as in the previous session. Our outline today, in this session, we're going to cover the master format specification sections, contract drawing, and a little bit about the resource drawings and the modifications of the contract documents. This is where we're at in the big facility life cycle. We're in construction documents. Today we're going to talk about specification. The technical specifications, or the specs, are part of the procurement documents, but they're also part of the contract documents within the larger family of the construction document. Keep in mind the specs are always complementary with the drawings, and they provide precise description and characteristics of the materials and products you plan on using. They set the standard and the qualitative requirements for the materials and the products. Keep in mind of that term qualitative when you're talking about specifications. Here's another image of it using our lineal process of where the specifications are. Now, it's important that you understand that drawings indicate the quantitative, meaning the size, shapes, and forms, and the specifications specify or indicate products and materials qualitatively in such detail that can be easily understood. Again, drawings are quantitative, specifications are qualitative. Basic steps for product selection are outlined. Primarily in the process, keep in mind that the development of specifications can come from many sources. Many of them are listed there. Many of the information, obviously, of the material comes from the manufacturers themselves, from their websites, and preferably from their product representatives also. After you've done the research, the drawings need to be reviewed and the project A&Es interviewed to glean all the project requirements that's necessary. Many architects, keep in mind, use their own corporate library or their own specifications. They use AIA Master Spec, which is preferred by large firms, or they use BSD's Spec Link, which happens to be owned by CSI, and is preferred by many medium and smaller firms. One of the things to keep in mind is that in BIM, 3D models are becoming more and more popular, obviously, in the industry, and specs information might be embedded in the BIM's model element in their attribute. And specs may be considered semi-automatically generated. That is, when information is put into the model, it'll put a notification that that particular product is being specified or needs to be included in the specifications. The problem with this automation is that the specs might be generic from the model and might not align with the corporate knowledge base or the firm's experience. It depends on the understanding and capabilities of the modeler themselves. Plus, until we model sealants, such specifications will provide very leaky buildings. So the basic steps, product selection. Again, you're looking at the products. How applicable are they? Is the manufacturer reliable? Have they been around in a while? Is the installation available? Is it tricky? Is it only certain installers can do it? What is the constructability of it? Does this have to be done in a dry climate when the factory happens to be in a very wet climate? And of course, cost is a big issue. Not only the affordability of the first initial costs, but also the overall life cycle analysis. When it comes to actually types or methods of specifying, there are 4 main types to remember. This is important if you're taking the exam. There's descriptive, performance, reference standards, and proprietary. Now, descriptive is the most common, and as it states, it's descriptive. You describe what it is. Performance, in which you're stating a performance requirement that you expect to get the end results from. And reference standards, that talks about basic common and accepted industry standards. Perfect example of that is ASTM standards. And the 4th type, which actually can be 4A or 4B, or sometimes they call it a 5th type. The 4th type is proprietary, which means you're calling out that specific manufacturer's product. And it can be what's called open and closed. Open meaning that you'll accept substitutions, or you'll accept alternate manufacturers that you may have listed, or closed, which means that this is the only product you want. Keep in mind that specifications often use more than one type or method of specifying a particular product. Now, to help make this clear to you all, let's use the 4 types or methods to specify a famous hamburger. If you're old like me, you remember the jingle about 2 all-beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. That's a very descriptive statement. Right? On a performance level, you say, I need something to eat. It has to be purchased quickly. It has to be cheap. I need to be able to eat it in my car. If it's a reference standard, you're going to reference it. It's going to be USDA grade A beef, number 2 fine wheat for the bun, etc., etc. On a proprietary level, all you have to say is, I want a McDonald's Big Mac. Keep in mind that the most common error in specifying is what's considered over-specifying, where one method conflicts with another. An example of this is what's written below. You can call out for a Conair 451 storefront, very proprietary requirement, fabricated from an ASTM aluminum, okay, and that product isn't necessarily made from that particular B429 aluminum. It's probably made from a B6063. So you're asking Conair now to make a special run of aluminum to make the particular storefront. And then on top of that, you put in a performance requirement that states it would be able to withstand a 50-pound wind load. And maybe your mullions are spaced that they cannot resist that sort of wind load. So this is an example of over-specifying, and you need to be aware of what needs to be. Okay. 1 is. This is what this image is what referred to as the big wheel. We'll send you an enlarged image of it later on, but it's included in the project delivery manual. This graphic shows the relationship with the contract forms, which are not specifications, and Division 01 sections, general comments, which are specifications. Keep in mind that the contract forms, the general conditions, supplemental conditions, are considered documents. They're not considered part of the specifications. Division 00 is not part of the specs. Keep in mind that Division 1 sections are also organized using section format, but they rarely have a Part 2 and Part 3. They're often just called out as not used. There are a few products that are specified in these sections, however. For an example, you may want to specify a specific temporary fence or an enclosure wall. Specifications are subject to administrative procedural requirements of the conditions of the contract and Division 1. Basically and keep in mind, as this identifies, the general conditions govern Division 1, which govern Part 1 general. So there's a flow-down relationship. These are often referred to as the three generals. Do your best to understand them and not get confused if you're taking the exam, because I myself have specifically written questions in regards to the three general for the exam. Keep in mind that division numbers never change. Okay? You'll need to remember the division titles, so spend some time, make up some flashcards, and remember which divisions cover what products. An example is a good way to remember Division 10 specialties is that we have 10 fingers, so we are special. Again, division numbers never change. If you don't use a division, you keep it in there and you just note it in the title as not used. You don't suddenly change over to the next division number. There are some sections that are set aside for future expansion. Again, a good way to remember Division 13 is that there's usually no 13th floor in a high-rise building, and this is considered special construction. Commit 11 to 14 to memory. Note that in the old CSI format, prior to 2004, there were only 16 divisions. And you still see this format being used today by many AE firms. Also remember that if you consider Division 00 as a division, that means there's not 49 divisions, but actually 50. Some of the service groups are included. These were expanded because originally Divisions 21, 22, and 23 were all looped together along with some other items in Division 15. Divisions 25, 26, 27, and 28 were all lumped together in Division 16. So that was primarily the reason why in 2014 these numbers were changed. I'm sorry, 2004, these numbers were changed. Another reason why was because all of civil work was thrown in Division 2. Obviously, they needed some expansion. So these were added so the Division 30 sections are reserved primarily for civil work. Now, process equipment used to be spread around the division. They moved them into the division authorities group. This is to help people who do primarily industrial work have a location for their processing specifications, equipment specifications. No need to commit these to memory, but just remember there are 49 divisions, and some of the numbers are reserved for future expansion. Now, when you go down into the various levels, once you get past the division level, there are multiple levels of specifications. The more the numbers at the end, the narrower the scope of the spec section, and the more detailed information will be provided. Really, the section really focuses in on a particular product or a particular installation. You need to memorize the following. The fact that a level 2 specification is considered a broad scope specification. A level 3 is considered a medium scope, and a level 4 is considered a narrow scope. Be able to recognize a level 3 specification or a level 4 specification. Each pair of numbers used signifies a different level of specification in the master format. We're going to go over this in a little more detail in the next few slides so you can get this concept down. Keep in mind that there's in master format numbering system that allows users to define a space for special circumstances. When we get down to what's called the level of details for specification, you can see that the level number increases, that as the level number increases, the scope becomes more narrow, meaning more specific. Each pair of numbers in the number strings define a level. 00s are used in level 1, 2, and 3 specifications for the highest level categories. Level 5, or the last 2 digits, is a user-defined. So if you have a very specialized product or installation, then you can write a section around just this particular building component. As you can see from the graphic, here the numbers are paired for each of the level. Be able to recognize a level 3 spec again compared to a level 2 specification. Here's an example. Note that level 3 specification has a 1 and a 3 in the third column, and the level 4 spec has a pair of numbers, 1 and 3 in the last column, separated by a period. All of these sections cover the same general topic, just an increasingly finite detail, or referred to as narrow scope. Not a reduced scope, but it's a refined or closer or narrower perspective on the scope. Also keep in mind that if you have both brick veneer masonry, okay, at that level 5 level, and concrete unit masonry on the same project, there's nothing wrong with specifying both in a section called section 04200 unit masonry, rather than thickening the spec book with duplication of all the other specification information repeated from 2 individual narrow scopes sections. So there's nothing wrong with doing that. Let's move on to contract drawings. Note that construction documents are inclusive of all documents in figure 11.1. Make sure you understand the difference of the 2 terms. While the specifications again identify the qualitative requirements, the drawings are graphic and they need to identify the quantitative requirements. Again, specs are qualitative, drawings are quantitative. The drawings cover the design intent and graphically indicate the relationship of the project elements. Circle the last statement. Remember that the drawings show location, identify the material, dimensions and sizes, details and diagrams of connections, and shapes and form. Drawings should locate the material, identify the component, give the dimensions, give details and diagrams, give only generic names, and identify, but not necessarily describe a material or a component. Drawings also indicate extensive alternates, construction phasing, limits of the work, specific areas of work by the owner, multiple contract projects, designated work based on separate contracts. They also identify symbols used in the schedule of symbols. Note that the first 5 bullet points here all relate back to Division 1. Drawings need to identify equipment by a short generic name or a symbol. Identify the components with really a bare minimum of information, and indicate the boundaries between materials of different capacities. Obviously, separating and sometimes expanding upon, exaggerating a separation between a material and a flashing and another material, for example. Some of the things that drawings should not do is use comprehensive notes, use too many notes, use notes that define work to be done by a specific contractor, unless it's a multiple prime contract, use proprietary names, and the worst thing is to put down C specs. C specs means that this is the only thing that you need to see in the specification. You don't need to see all the rest of the items that you specified or that you've shown on your drawings if you didn't say C specs. So don't put C specs on your drawings. Going back to some of the things that Suchi talked about in the drawings and the project stages, remember that in the conceptual design, drawings are included in some basic drawings illustrating the extent, scope, and aesthetics, massing concepts and some elevations and spatial configurations and sizes. When you get into schematic drawings, they'll start showing some dimensions in a little bit more detail. This is the phase that renderings are typically produced. A rendering cannot be generated until the elevations and the character of the building is established. This is the phase in which preliminary project descriptions are prepared rather than outline specs. Schematic design phase, you're doing preliminary project description. Keep in mind that when doing preliminary project descriptions, you're going to be using UniFormat in lieu of MasterFormat, or the format of those. In the DD phase, or design development phase, more detailed information starts building cross sections and basic systems are developed. The spec format will shift from preliminary project descriptions to an outline specification, using now the MasterFormat organizational system. These drawings might equate to a 30% design completion. CDs, or construction drawings, are produced stages. You normally see them at 60, 90, and 100%. They get more detailed with each submittal and are complemented with full sets of specification, typically using the MasterFormat system. The 100% CD drawing, along with the contract forms and specifications and contract modifications, form what are known as the contract documents. Note that the level of detail of the CDs will vary depending on the type of project and the delivery project method used. For instance, the design-build project may have less detailed drawings, for example, just some code minimum drawings. Construction drawings include shop drawings and supplemental drawings for changes and clarification. But shop drawings are not contract documents. You need to refer back to A201 as we originally discussed. Record drawings are important for the owner in future additions and modifications. They are vital to the facility or building manager for future reference. Record drawings need to be maintained at the contractor's field office during construction, not at the home office. They need to record all changes. Changes during the course of construction are marked up on these drawings, and this includes items of modification issued such as field orders, ASIs, construction change directives, and change orders. During the project closeout phase, the drawings are typically turned over to the owner. Sometimes the owner, however, will request the architect to update their CAD files or their models to reflect any changes. These record drawings may include a paper copy or maybe an electronic form. If a BIM modeler's CAD file has been used, then contractor may have software and update this and provide it to the project team. Obviously, this needs to be included up front. Drawing coordination is very important, and a coordinator should be assigned to the project to ensure consistency. If the architect and engineer is not the specifier, then a coordination meeting with the specifier is required to ensure that the specs are aligned with the drawing. Checklists are a common QA tool used by specifiers with the project team to help QC the CVs and ensure that products in the drawings are covered in the specification. Spec writers, therefore, are inherently QCers of drawings. The drawings shown here are an example of a key plan. Note it doesn't have any dimensions, it's just a reference plan. There are scaled and non-scaled drawings used in the development of construction documents. Scale drawings will include a numerical scale, for example, a 1/4 inch to a foot, or a graphic scale are commonly used since drawings might be printed half-size or issued as PDF. Note that although commonly accepted as a practice, there should not be a defined order of hierarchy in drawings. For example, stating that larger scale drawings take precedence over smaller scale drawings. If the drawings are complementary, then they all work together, and what is required by one is required by all. If there is a conflict, then a question must be asked to clarify the design intent. Non-scale drawings and details need to be labeled, not to scale. Again, the drawings and specifications need to be coordinated. The drawing materials labeled be consistent, and materials and products shown must also be included in the specification. Drawing blocks. Drawing blocks are common for BIM and CAD files and are often produced by manufacturers for insertion into a set of drawings. The arrow pointing to the stud of this detail might be a block that will be used many times. There might be more than one block in the drawing detail. In a BIM model, the block or element might have attributes, and in some cases the specs for that item might be embedded within that particular element. For example, a door block or a door element might have the material called out, whether or not it's wood or metal, a thickness, a fire rating, interior and exterior applications, and even the hardware type embedded within it. Keep in mind that the modelers may not be aware that that data is included within those elements, and you may end up with a hardware section or a hardware specification that's completely different than what you're thinking of. So, as we said, specs can be linked with these blocks or elements with eSpecs or LinkedIn, and can be automatically generated, but there still needs someone to review the specs and review the documents. Finish and hardware schedules are often included on the drawings, but they also might be in the specifications. Here's an example of a door and frame schedule. With greater use of BIM in the development of CDs, it's not uncommon to see a rendering or isometric drawing used in the set to help clarify the building date. One issue that has yet to be worked out with BIM is who owns the drawings, who takes responsibilities for the accuracy. What if the model has a bust dimension or a detail? Whose responsibility is it? What level of detail is going to be provided? This level needs to be consistent throughout the entire drawing set. Isometrics, for instance, are very useful in detecting conflicts and resolving conflict resolution. Some contractors develop BIM models of interstitial spaces above ceilings to ensure the ductwork doesn't conflict with the structure and the fire sprinklers and the light. There is no need to add notes on the drawings that say these specs. This is redundant and useless, especially if the drawings and specs are complementary. In a CD specs set, there may be a nomenclature set up of symbols to be used throughout the drawings. These symbols and notations obviously should be consistent. The letters in front of the drawing numbers need to be consistent. A for architecture, S for structural, M for plumbing. The drawings and the layers need to be organized in accordance with some standard. National CAD standard is a great standard to follow. CSI's drawing format, called the Uniform Drawing System, is another system. Note that these are recommendations, they're not mandated requirements. Each office may vary with their own standards, and in particular, the particular clients may have standards that they want you to follow. There are a number of influences on the organization of the drawings. Note that the project phases, sequence of construction, and project delivery method may impact the organization of the drawing. Project delivery method will also dictate the cost of the work that the AE will incur when developing the set of drawings, especially if the drawings are issued in multiple bid packs in a fast-track model used in design, build, or construction management. It's important to be familiar with the term UDS, or Uniform Drawing System, for CSI. And the formats out there. The National CAD Standard is a consensus standard, but it's not mandated. It comprises several industry sub-publications listed here. NIBS means the National Institute of Building Sciences. Be familiar with these terms. Some trends that we're seeing. Integrated project delivery, or IPD, and BIM are linked at the hip because of the collaboration efforts to design such a project delivery system. The AE may come up with a basic model, and the trade contractors will design and fill in the details. Projects teams share the model and collaborate on the design. In order for this to occur, the software used by each discipline must be compatible and interoperable. As stated earlier, one of the benefits of integrated project delivery is cost control. Decisions made early in the design process often have major impact on the cost and the schedule associated with the project. DSA has specific understandings of what they see BIM used for. They see it as a data-rich, object-based, intelligent, parametric digital representation of the facility. Keep in mind that GSA is the largest building owner in the United States as far as square footage is concerned. So now they're requiring all their building drawings to be using BIM for a couple of things. One, for energy modeling, and the other thing is for simply keeping track of what tenants they have in what spaces. NIBS has their own definition of BIM as outlined here. The BIM definition, according to CSI, is a three-dimensional geometric model plus data on building elements and systems, wall and door types, space characteristics, air handling units, all various components that go into it. The organized prototype of a building contains data used by building analysis software applications such as cost estimating or energy simulation, daylighting, code checking. And they have what's considered to be high intelligence, or basically easily usable data. CSI sees BIM as 3D CAD plus information plus collaboration. Make sure you understand that BIM, typically considered 3D, when you add scheduling and sequencing to the model, that's called BIM 4D. When you add cost to the model, that's referred to as BIM 5D. You're adding facilities management and as-built reference information into it, it's 6D. I like to refer to this as simply XD because you never know exactly what level you're going to be getting. But as far as those taking the exam, these are the numbered steps and the level of detail in the BIM model that CSI portrays. These are some of the BIM goals presented here just for general information as to why we're utilizing BIM in our industry. Keep in mind that BIM is evolving. Software is evolving, still in its larval stage of development in some respect. There's a lot of lack of information about design intent or decisions or analysis or code requirements. That may be changing here shortly. There are a few programs that actually capture the O&M data in any sort of organized way, although there are definitely companies working on that process. It's a continued research and development within the industry itself. Academia, use of the software is expanding it in multiple directions. There's beginning to see more interoperability between the various software packages, so you're not just stuck with one particular software. You can work with other people's BIM models. And there's an integration of the specification, not customized for office standards, but a concept of being able to share qualitative information within the model. Questions to address when using BIM is: who owns the model? What is the level of detail expected? Who's responsible for errors if you pass along the model to other people? And are you expecting to have integrated specs, the information included in the model, or is it simply a reference back to a pointer within the elements of the model? We conclude with talking about the resource drawings. Keep in mind, resource drawings are not contract documents. We'll be covering this in a future session, but they are part of the larger family of construction documents. We'll also cover modifications. They're issued after the contract is awarded and signed. We'll cover this topic as part of the session on construction. Remember that these modifications are contract documents. They differ from addendums that are issued during the bidding and prior to the contract award. Quick review of what we covered today. Are there any questions? In that case, we'll close out the session. Appreciate it very much. Your next presenter is Steve Ryan, and he will close out session part 3, I can say, of construction documents and talk in more detail about specifications. Thank you all for listening.